Hello, this movie is for Learning Target 5, angles formed by chords, secants, and tangents. Let's look here. Let's find first the measure of angle 1. Now, if we're trying to find measure of angle 1, notice how it's supplementary to that angle. And to get this angle here, we know that 30 plus 70 plus that angle x should equal 180 because all the angles of a triangle add up to be 180. So if we figure out 180 minus 70 minus 30, that gives us that this must be 80 degrees. And if x is 80 degrees, then 1 is 100 degrees. So we know that the measure of angle 1 is 100 degrees. Now, to get the arc AD, notice the inscribed angle. If you pull that back, you connect these guys. You get the inscribed angle of 70. So this must be twice that, 140. And to get the arc BC, we can see that 30 opens up to that. It's an inscribed angle because the vertex is on the circle. So this is 60. So if we add these two together, 60 plus 140 gives us 200. What is the relationship between these two measures? Well, angle 1 seems to be half, 100 being half of 200, of this arc plus this arc. So I know that the measure of angle 1 is equal to half the sum of AD plus BC. And AD and BC are both considered the arcs created by angle 1. So angle 1 being here, these are the intercepted arcs. So it's half the sum of those arcs. And that's one of the properties we're going to look at today. Notice how in that warm-up problem, our intersection of the two lines was inside the circle. And when you have those two lines that intersect inside the circle, the angle measure is half the sum of the intercepted arcs. And so that's what we see. We add the two arcs, x and y, and then take half. Notice we can also have lines that intersect, but where they intersect is outside the circle. And when that happens, you get two intercepted arcs, x and y. Same thing here, x and y. Same thing here, x and y. But because those two lines intersect outside the circle, it's half the difference of those arcs. And that's what we're going to be talking about today. Half the sum when the lines intersect inside, half the difference when they intersect outside. The lines from a point outside the circle going through the circle are called secants. So AB, line AB is a secant. A secant is a line that intersects a circle at 2 points. Notice these 2 points, if I connect between those two, I get a chord. So a chord is part of a secant line. AB is a secant. Ray AB is a secant ray. Segment AB is a secant segment. A chord is part of a secant. So we say CD is a chord. Here, we're noticing how the two lines intersect. They intersect inside the circle. So what I know is that the measurement of my angle X is half the sum. And what is the sum? The sum will be the sum of the intercepted arcs, which will be 90 plus 46. So we do 90 plus 46, take half. Oh, let me get the calculator here. So we get 68 degrees. Over here, the two lines, where are they intersecting? Outside the circle. And so therefore, we're looking at these two arcs, this arc here and this arc here. Now, when you're taking the difference, it does matter which one you write first. So we have to be very careful. But the angle measure, which in this case, we're given the angle measure, 20, is equal to half the difference of the intercepted arcs. And we always work our way in towards the angle. So we do 95 minus z. So That totally would be different than z minus 95. So you got to make sure you're working from the outside in towards the angle. So we're solving this guy. I'm going to multiply both sides by 2. That gets rid of the 1/2. And I get 40 equals, these cancel, 95 minus z, or x. Then add z, subtract 40, and we get z is 55 degrees. What is the value of the variable? The two lines intersect outside the circle, so the angle measure that I get here, in this case is 70, is equal to half the difference. And I'm going to subtract going this way. So the arc on the outside, subtract the arc on the inside. So it's going to be W minus 110. And so I'm going to solve this equation by multiplying both sides by 2. That gets rid of the 1/2. So 140 equals W minus 110. Add 110, and we get 250 equals W. What is the variable down here? Well, y, which is outside, they intersect outside the circle. In this case, our angle is y, is equal to half the difference of our intercepted arcs. Difference because they intersect outside the circle. 110 minus 30. And we're just calculating this, and this will give us 40. Okay, let's go to the next page. What is the value of the variable? Here the lines intersect inside the circle, so the angle that we have, 35, is equal to half the sum of the intercepted arcs, and it doesn't matter which one you write first because adding is commutative. I'm going to multiply both sides by 2, and I get 70 equals x plus 30. Subtract 30, and I get 40 equals x. So that arc measure is 40. Here, the lines intersect outside the circle, and so my angle measure, 44.5, is equal to half the difference of the arcs, working our way in, x minus 41. So we're going to solve this, multiply both sides by 2. And then we're going to add 41. And we get x is 130. Satellite is an orbit. It's intersecting obviously outside the Earth. It has a viewing angle of 17.5. What are the measure? The arc. So what we're trying to find is this arc, how much of the Earth can be viewed. So I'm going to write that as x. And because this is a full circle, the outside is going to be the blue part. And I can't introduce another variable, or else this will be a hard equation to solve with 2 variables, 1 equation. So instead, I'm going to write the other side in terms of this variable. I know that it's 360 degrees all the way around, so this would be 360 subtract x. So we say that 17.5, our angle, is equal to half the difference. And the difference is going to be of 360 minus x minus the interior angle x. So this guy's that inside angle, this guy's that outside arc. Sorry, inside arc and outside arc. So that's the equation we use to set up. We can multiply both sides by 2, and we get 35. This is 360 minus 2x, and then just solve this equation. So when I subtract 360, I get negative 325 equals negative 2x, and then I divide by negative 2. I get 162.5 degrees. And so this one you can do on your own. You can pause the movie, press play when you are finished, and see how you do. Okay. So your equation for this one should be that 20 is equal to 1/2 360 minus x, and then you solve this and you get 160. So that's the end for this movie. Thanks for watching.